All right, guys. So I now wanna ask the question: what happens when the bases are not the same? Right? We will have to solve these problems where the bases aren't the same. It would be really nice if the bases were always the same, but look, let's be real. They're not always going to be the same. Let me start with this problem right here, which says e to the x. Guys, way too much noise. Let me start with this problem right here, which is second one down there. I'll come back to the first one. I'll sort of loop back. So, it would be really... Chun-Li?
Is that still under cancellation?
No, this is a new strategy because cancellation of bases is not going to work here because the bases won't be the same, right? So this is the whole deal. The bases are not going to be the same. It's a new solving logarithmic equations. Yeah, I mean, there's no real rule. It's a topic. So here we are. Ideally, these would all be base e. Remember, e is a number. Ideally, we could write all of them as base e, do some cancellation. Unfortunately, that is not possible. 10 cannot be written like e squared or e cubed. Remember, e is a number, 2.71. So let me model through this problem exactly how to do it, and we'll take the questions at the end. Those who are good, go on. Right? Okay. So step one is I want to get all these variables on one side. That was like an Algebra 1 topic. Get all the variables on one side. So I'm going to divide by e to the 3 minus x. Use the logic that you've already learned. Use the logic that you learned way back in different grades and just apply it to this problem. That's all we're doing. E to the x plus 1 over e to the 3 minus x equals 10.
Why?
I just divided e to the 3 minus x on both sides.
Oh, yeah.
Okay, now, we have our exponent rule. We talked about it on Monday. If the bases are the same, and I'm dividing, I subtract exponents. If the bases are the same and I'm dividing, I subtract exponents. The bases here are the same. E is a number, 2.71, 2.71. Bases are the same. Dividing, let me subtract. So I'm going to write this as e to the x plus 1 minus 3 minus x equals 10. Remember the rule we learned, x over a. Excuse me, x to the a divided by x to the b is x to the a minus b. That was the rule we learned. Right now we're just going to apply that rule here. So now, let me simplify the exponent a little bit. So I'm going to go e to the x plus 1. Negative 1, I'm going to distribute that here. Negative 1 times 3 is negative 3. Negative 1 times negative x is x. And that's equal to 10. All right, so now we've got, let's simplify this some more. So we've got e, x plus x is 2x, 1 minus 3 is minus 2, and that equals 10. All right, this is the money step. This right here is the money step. At the beginning, we had multiplication and we used division to get rid of it. In other instances, you may have had addition and you use subtraction to get rid of it. When you have a number, a variable in the exponent, you use logs to get rid of the exponent. Let me model what I mean by that. Just stick with me for 2 minutes. This will all become clear. I'm going to take the natural log of both sides, ln of both sides. I'm going to move up here so I have more space. So I've got ln of e to the 2x minus 2 equals ln of 10. Go back to Tuesday's class. Log property. We said if there's a power, it comes downstairs in front of the log. We said if there's an exponent, we bring it in front of the log. This is Tuesday's class. Should be in the notes. On the Khan videos as well. 2x minus 2 times natural log of e equals natural log of 10. Remember, power downstairs in front. And here's the beautiful part. This is why we use natural log. Natural log of e is 1. That's the beautiful part. Because remember, this is a base of e here. E raised to what power gives me e must be 1. This was a property on Tuesday also. called log of the base. So if this is 1, 1 times this, well, that's just what it is. That's the identity property. 2x minus 2 equals natural log of 10. And now I'm back to basically something that could have been an algebra problem. Natural log of 10 is a number. I don't really care what it is. I don't really know what it is. Doesn't matter. Solve this just like you would solve any algebra problem. Add 2 to both sides. And I've got 2x equals natural log of 10 plus 2. Divide by 2. And right here, you have our final answer. Some people want to simplify. Doesn't matter to me. You can do it if you want to. You don't have to. Some people want to put this in their calculator. Why? Don't waste the time. Don't risk typing something in that's wrong. This is the answer. Done. Shun Li.
So we don't have to find the natural log of 10 and solve it.
No, because this is more exact. If you like to do this, then you have to round. This is a more exact answer. This is a better answer. This is a better answer. Let me stop here and see if there are questions on this. Leslie.